A very good day, students. This coding uh, it's about the introduction that we did last week. I had forgotten to record the session last week, so basically I'll just be repeating myself, and yeah, I guess it will also benefit those that were not available during last week's session of introduction. So, ladies and gentlemen, as mentioned, this is the introductory session. Um, so we'll first, so we'll be discussing electro-pneumatics for our labs, right? So first things first, we will set up the software. As I mentioned, I will be uploading the software for you guys so that you can use on your personal computers, right? So first things first is that you will find a folder written FluidSim 4.2, and then you'll click into it, and then you will go down and click on setup, right? You'll double click there, right? And then you'll click yes once you get that pop-up, and then you'll get this window, right? That says welcome, and then it's, yeah, the brand is Festo, right, that we're using. So I'll click next, and then you'll choose restricted student version, right? This is important for you to do, right? So you'll click on it, and then you'll click on agree, and then you'll click next up until you finish the whole process, right? Okay, you'll get this window. This is how it's loading, right? Um, and then you'll also get this window. You'll just click finish, right? And then you should be done with your installation of your software, right? And then you can search for it, FluidSim. So it's FluidSim Pneumatics version 4.2 student version, right? So we'll click on it and open it and start with our discussion. Okay, so you should see this window once you have opened your software, right? You'll just click OK. There was a window that I couldn't show on my side, but yeah, when it comes up, you'll just click OK, right? So this is your environment. This is your FluidSim environment where you'll be writing your pneumatics what's this? Your pneumatic diagrams along with your electro-pneumatic diagrams, right? So just a brief um, overview of your environment is that you'll see a ribbon, right? It has your functions like your files, where you save your files, right? Um, your edit mode, execute, library mode, insert, dietetics, project, view, options, and window, right? So you can explore them in your own time, right? So one of the important things that you must note is your hierarchical view, or otherwise known as your component library, right? Now, your component library is divided into pneumatic, electrical controls, digital technique, easy port. This one we'll be using later on as we proceed, right? This is where we'll be using ladder logic. So we'll be using FluidSim to connect to codices, which is a platform where we can write our the same. We can run our code using ladder logic, right? And then here it's your miscellaneous. This is like when you want to put text, comment on your diagram that you have drawn. Okay, so ladies and gentlemen, I'll just so for this semester in our labs for automatic control, we'll be going over we'll be learning about the basics of electro-pneumatics, right? So you might ask yourself, what is electro-pneumatics? Um, so basically, electro-pneumatics is the use of air, right, to actuate your system. In this regard, to actuate your cylinder, right? Um, so you're using air to actuate that cylinder using an electrical signal, right? Hence the term electro-pneumatics, right? Um, so yeah, that's basically what we'll be doing. That's the long and short of it in terms of definition of what electro-pneumatics is, right? Okay, so when you want to start with your simulation or your pneumatics diagram or pneumatics drawing, what you'll do is that you'll go to the top left corner, and where you see that new symbol, you'll click on it, right? And then and then this is your interface. This is where you'll be drawing your pneumatics circuit, right, and your electric circuit, right? So first things first, let us discuss um, the components that are are important for us to know about, right? Before we can start simulating our model, our diagram, right? So if you can click on the plus sign under pneumatics, you will further get different groups, right? You'll get like supply elements, actuators, valves, valve groups, measuring instruments, and sensors. You should note that we will not use all of the components in this library, right? But you are more than welcome to explore on your own time other components and what their function is and so on, right? So as mentioned, we are using electrical signals to uh, we are using electrical signals and air to bring about actuation, right? So first things first, what we need a compressor. This is the most important component, right? Because it's responsible for all the work being done, right? Now, your compressor brings in compressed air into the system, right? Now, for those interested in seeing how a compressor looks like or how the components look like, what you can easily do is that you click on the component and make sure it's grayed out like that, and then you right click on it, and then you get an option. You want to see a component description, um, giving an explanation of what that component does, and then also you can click on the component photo to see how our compressor looks like, right? So that is how our compressor looks like in real life, right? You are also welcome to come look at it in our lab, right? Um, so yeah, that's how our compressor look, and then the description is so the compressed air supply provides the needed compressed air. It contains a pressure control valve that can be adjusted to output the desired operating pressure, right? So that's what our compressed air supply does. Okay, so we are so these labs are practical, right? So right off the bat, we will be answering a question, right? So let me open an exercise. So we'll answer this exercise, but at the same time, I'll be explaining each and every component and just explaining how everything works, right? So this file of the exercises has been uploaded for you guys, so you can go over the exercises in preparation for your labs, and yeah, we can, yeah, so that you can better catch grasp with the content during lab sessions, right? So um, in this exercise, we'll be going through inspecting beverage crates, right? So we'll be using pneumatics to answer electro-pneumatics to answer this exercise, right? So as mentioned, so let us read our learning objectives and the description of the problem to get a better idea of what we need to do, right? And how everything works, right? So learning objectives, you'll be familiar with the setup and function of a single acting cylinder, right? You'll be familiar with the setup and function of a 3-2-way solenoid valve. You'll be able to explain and set up direct actuation, right? That is what we'll be doing for today, for this session, introductory session. So this description of the problem, right? And I'm sure you can appreciate also the picture. You can, yeah, I'm sure it gives a better mental image of what the problem is about, right? So the description of the problem is as follows. Beverage crates are checked for completeness with the help of an inspection unit, right? This unit being our cylinder, right? Incomplete crates are pushed off of the roller conveyor by pressing a push button, right? Develop a controller with which this process can be executed, right? Going to the next slide. Another thing to mention is that the exercises I'll be giving you, they are not in the form of a PowerPoint, but a PDF. But it's the same exercises as mine in the PDF in the PowerPoint presentation, right? So exercise 1, description of the process. This is a further description, right? After pressing a push button, incompletely filled beverage crates are pushed off of the conveyor by the piston rod of a single acting cylinder. I will shortly show you what a piston rod is, right? When the push button is released, the piston rod is retracted to the rear end position, right? Um, so you can read more details about your single acting cylinder, but I'll explain it. I'll just summarize the explanation, right? Okay. So let me explain a bit about direct actuation. So let me zoom in. So when the push button is actuated, current flows through the directional control valve solenoid coil. The solenoid picks up and the directional control valve is switched on the actuated position, right? The flow of electrical current is interrupted when the push button is released. The solenoid drops out and the valve is switched to the normal position. All right. So I'll explain in a different way about direct actuation, right? Um, yeah. So for our circuit, um, the components that we need are within our statement. So it's important to be able to note the keywords, right? So for this exercise, we were told that after pressing a push button, so you know that you'll be using a push button, right? Let me just go here. So they're saying, okay, so once you get this learning objectives, they will tell you which components to put onto your workspace, right? So they're saying you'll be familiar with the setup and function of a single acting cylinder, right? So let us put our single acting cylinder. You'll find it under actuators, right? And then as you hover over a component, you'll see single acting cylinder. So let us put it there, right? So let us talk about our single acting cylinder, right? So our single acting cylinder, according to this diagram, is made of a piston rod. So this white rectangle is your piston rod, right? And this black color here, this black shape is your chamber, right? So that is where the air comes in, right? And then these triangular pattern is your spring, right? Otherwise known as your spring return, right? And then this circle here, if you can hover your mouse over that circle, is your inlet port, right? So your inlet port is a pathway where it's where your air comes in, right? So once your air comes in this pathway, it'll come into your chamber, your cylinder chamber, and then it'll actuate your cylinder or your piston rod, right? So that it can extend. Currently, your cylinder is in the retracted rear end position, but like should the piston rod extend forward, that is the forward end position, right? So it's important to differentiate between the two um, state positions, right? But you understand more once we start simulating, right? Now, the other component that we are told that we need for our exercise is that you'll be familiar with the setup and function of a two-way solenoid valve, right? So let us put our solenoid valve onto our workspace. So you'll go to valves, and then we will go to frequently used wave valves, and then you will click on the solenoid operated valve, right? Because it's electro-pneumatics, we will only be referring to the solenoid operated valves, right? So if you can further click on that symbol, plus symbol, you will see all your components, all your solenoid operated valves, right? Now they're saying we need a two-way solenoid valve. Now, what's a two-way solenoid valve, right? Let us go into that detail, right? So for this case, you'll need a okay. So if you can hover over your component, there it is, two-way solenoid valve. But like we have more than one two-way solenoid valve, right? I'll explain the other one if the application requires us to use that one. But for today's session, we're using the two-way solenoid valve with a spring return. Now, if you can see at the end of your component, there is like a zigzag pattern, right? That is just to tell you that your button acts using a spring return. So immediately once you click onto your button and then once you click, your spring will compress, and then once you release your finger, your spring will return. So that's why we call it a two-way solenoid valve with a spring return, right? Um, so uh, interrogating our component further on why we call this a two-way valve is that if you can pay attention, uh, also pay attention to my cursor. So um, the component is like it's like a rectangle and then with two blocks, right? That's why we call it like that's the two-way in two-way, right? In that name, two-way. But like, where is the three coming from? The three is coming from our ports, right? So if you can see where I'm hovering, it's that port is port number one, right? And then up there is port number two, and then up there where I'm hovering is port number three. Now, what is the difference in those ports, right? Those ports, the port number one is your inlet port, right? This is where your air from your compressor is coming in, right? And then port number two is where the air is coming out and going into your cylinder, right? And hence direct actuation, right? So uh, Another thing you must observe that's why we call it a two-way valve. So it's a three-port two-way valve. That's another way of calling it, right? So the other thing that you should be observing are your arrows, right, inside your blocks. Now, this arrow tells us that this is a normally closed two-way solenoid valve. Now, we have two kinds of states when it comes to valves. We have your normally closed. This is what we're seeing, the normally closed. And then we have your normally opened. Now, you might ask, what is the difference between the two, right? Two states. So your normally closed state, as we are seeing here, is that um, it our valve doesn't automatically allow our air to go through to the next component, that is our cylinder, right? So what this component means is that what it's telling us is that fine, your compressed air will travel and will get into port number one, but like I will not allow you allow the air inside this valve to go through into the chamber of the cylinder up until you actuate, up until you press a push button, right? So that's how a normally closed solenoid valve works. And this arrow, right, that I'm showing, that I'm pointing at, that is looking upward, is like your is the one that connects to our pneumatic line. So this line next to these T sh- T T looking symbol, the line in the middle is your pneumatic line, right? So once this arrow aligns with your pneumatic line, that's when air is allowed to flow through, right, the valve and then into other components, right? One of them being the cylinder, right? So that's your two-way valve. But there's more to this, right? So if you can hover at the beginning of your component, if you can hover over here, you'll see a green light, right? Now, and if you can double click, you'll see this pop up, valve solenoid connection. Now, what does this mean? This is when you are creating an electric signal between your solenoid valve and your valve solenoid. So as you can see, they're saying under the label, they're saying corresponding component of electrical circuit, and then they show your valve solenoid. So what they mean here is that this valve solenoid of ours can only communicate with this valve solenoid, right? Um, so your two-way solenoid valve can establish an electrical signal using a valve solenoid, right? And it's important that your label of your two-way valve solenoid is the same as your valve solenoid, right? I hope it's not really confusing using so much of the words valve solenoid, right, for these two components. But yeah, I hope it's clear, right? But um, for further explanation, you're more than welcome to consult, right? So yeah, but we'll get to the labeling shortly, right? So for now, we can just click OK, right? So ladies and gentlemen, one thing before I forget, this diagonal arrow here that is pointed at port 3 is where your air leaves the exhaust. So uh, your valves, either it be a 3-2-way or 5-2-way, which are the ones that we'll be using for our labs, all have an exhaust valve, right? Um, we we Valves are important, you know. I mean, exhaust. I mean, this is your exhaust port. Exhaust ports are important for most of electronic components, right? Or components that are subject to pressure, right? Why might that be an importance to have an exhaust valve is that you always want to relieve your system, right? In our case, we don't want pressure being stuck in our component. You know, that might lead to faster wear and tear of our component, for example, so we want like a cooling mechanism in a way, so that port 3 or exhaust port is responsible for, right? So basically that is our two-way valve, how it functions and its purpose, right? The other learning objective for us, you'll be able to explain the setup of direct actuation. So when your valve, uh, you connect it to your cylinder, as I've done just now. So how you do that is that you, let me just delete and repeat. So how you do that is that you hover over your port 2, and then you click on it, and then you drag it to the port of your cylinder, right? So when you are having such a system where your compressor is connected to your valve and your valve is directly connected to your cylinder, that is when we say you have achieved direct actuation, right? But we are not done. Our circuit is not done. You could easily run this, but it would be impractical. Why? Let me just run it for explanation's sake. So if we would run it, it would run just like how the exercise is instructing us, right? As you can see, if we clicked on the run button, if you click, hold it, you can see that your cylinder um, has extended, right, to the front end position, right? And then if you can release from that button, that spring inside the cylinder will automatically retract our piston rod, right? And another thing to observe is that there's a dark blue color and the light blue color. What that means, the dark blue color means that this is our air coming from our compressor. But as I said, this is a normally closed two-way solenoid valve, and it doesn't automatically release our air into our cylinder, right? So it's stuck in this valve, right? But it only lets out air once we connect our pneumatic line to that arrow that was that is pointing upwards, right? So that's when now air is fully circulating, uh, and then you are having actuation there. Then if you release, it comes back. But the reason I said that this is impractical is because your 3T-way solenoid valve, if you can look at the component photo, is that if you look here, there isn't any push button, right? So it's impractical, and yeah, we have not answered our exercise 1, right? So how we do that is by having an electrical connection, communicating with our pneumatic components, what's this, electrically via electrical signals, right? So let's do that. Before that, uh, it's always advisable, or it's a good practice to have an air service unit. So I'll explain what an air service unit is. So our air service unit, let us rotate the component so that we connect on the side or where the air is directly going to the filter. So before that, your air service unit, let us go to the component description. So the service unit is made up of a compressed air filter with water separator and a pressure control valve, right? So your air service unit is capable of filtering dust particles, right? And allowing for clean air to flow through your system, right? Without this, your components will wear and tear quicker than they should, right? So we always connect the compressor to the side where the air filter is, right? So I like to rotate my components. So how we rotate is in an anti-clockwise direction, right? That's how the software is set up, right? So if you click on the 90 degrees, you would have rotated your component like that. Okay, so let us connect our compressor to the air service unit, and then the air service unit to the 3-2-way solenoid valve, right? So pneumatically, we have successfully connected our circuit, but we have to answer it from an electrically point of view, right? Via an electrical circuit, right? So how we will do that, and by the way, this is how an air service unit looks like, right? So that's how an air service unit looks like, right? So to answer our question, we will need the question said we need a push button, but first things first, uh, you'll always be doing this, right? We need a first things first is that we will need a, let me just minimize just a productivity tip. It's best to, once you're done using a component, just click minus to minimize and to better see your what's this, your library. So you will go to electrical controls, and then you'll go to our power supply, right? Um, which I'll show you how it looks like. So we'll need a 0 volt, then we'll need to rotate this 180 degrees so that we can get a connection. So we'll connect from this point to this point, and then let's just make it neater. And then you'll need your 24 volts. Then you'll need another one. And then you can right click and then rotate 180. You can always also copy and paste, like you can say control copy, then control V to just copy another one instead of dragging it, taking it from the library and dragging it into your workspace, right? So that's just a tip. So let us connect from this point to this point. Okay, so we've established our power supply, right? And just a picture of how our power supply looks like. That's how our electrical connection looks like, right? And I think it's the same visual as our 0 volt, right? But in the lab we have, yeah, we have a similar um, component, but a bit different to this one in the picture, right? So the exercise, going back to the PowerPoint, we are told that beverage crates are checked out for completeness with the help of an inspection unit. Incomplete crates are pushed off of the roller conveyor by pressing a push button, right? Develop a controller with which this process can be executed, right? And further explanation, after pressing a push button, incompletely filled beverage crates are pushed off of the conveyor by the piston rod of a single acting cylinder. When the push button is released, the piston rod is retracted to the rear end position. So it goes back to its original position, right? So yeah, so let us answer our question. So let me close this window. So we are going to actuate our cylinder using direct actuation. So what we need, right? What we need is switches, right? So under switches, you'll go to manually operated switches, and then we'll go for the first option, the push button make, right? So I'll click and drag onto our workspace, right? Um, something that I would like, something that I see as best practice is labeling your components, right? Not all of them, but like um, it's important to name your push buttons, um, your emergency stop buttons, to name your relays, to name your solenoid valves, right? But yeah, as I'm working, you'll adopt. I believe you'll adopt the culture, uh, because I think it's best practice and it will make for easier readability of your circuit, right? The should should your manager look at your diagram, they won't find it hard to see what's happening because you have labeled your components, right? So yeah, how do you label is you can double click and then you can label this our push button. You can just just write it PB, push button, right? And then click OK, right? And then you'll connect port 3 to the supply, and then port 4. Before that, because we said we are dealing with direct actuation, our push button is connected to our solenoid valve, right? For this one, we do not have a photo. I believe it's because of our restricted license, or the version of the software, right? So if you can click component description, an electric connection uh, is a place where an electric line can be. Okay, I think this is not okay. It seems like okay. It seems like they don't have a clear description. But what you should know is that your solenoid valve is responsible for communicating with your two-way solenoid valve, right? Um, and earlier I mentioned that we have to label them the same using the same names, right? But for now, let us connect our port 4 to this port, and then this port to this supply line, right? Um, okay, let's make it neater a bit. Okay. Uh, okay. Um, so yeah, uh, with this having been done with this circuit, this is what we call direct actuation, right? But like in order to see if our thing is correctly running, let us press play. And what should happen is that when we press our push button here, our cylinder should extend, and then when we release, it should retract, right? So let us click start, right? Now, as you can see, the air, dark blue air, this is our air that wants to go into the cylinder to extend it, but we can't because this is a normally closed two-way solenoid valve, right? So how we allow the air to pass is through the push button. So if you can press it, you'll see that as you press it, nothing is happening. Why? It's because your solenoid valve is not communicating with your two-way solenoid valve. So I did that on purpose, right? So how you do that is that how you allow for the electric signal, how you allow for communication between your pneumatic components and your electric circuit is by assigning the same name to your valve solenoid connection, right? So you can name it Q0, and then we can name our valve solenoid also Q0, right? And then you click OK. Now we have established an electrical signal. So once we press our push button, this cylinder should extend. And then once we release our finger off of the push button, the cylinder should retract to its rear end position, that is its original position. So pressing the play button, start button, you can also alternatively press F9, but yeah, pressing it will get we'll get this diagram like before, but like now it's working, right? Because we've established the connection. So if you click on it, as you can see, the power source in red from 0 to 24, it's going through the solenoid valve, through the push button, and then to the 24 supply, right? And then because my finger is still on the push button, the cylinder will not retract. But once I release, and because of the spring return, your cylinder will go back to its rear end position. And that, ladies and gentlemen, is us answering um, exercise 1, inspecting beverage crates, right? So yeah. So yeah, this was the introductory session, and yeah, we will explore more components, more exercises, and yeah. So that is the end of the session, and yeah, One of the thing to that you should note is that I I am available Monday to Friday. Should you seek counsel, I'm in 1304 John O Building or 1108 John O Building. Right. All right. Enjoy the rest of your day.